Hello everyone, welcome back to my class of trigonometrical ratios of class 9. In the last class we have already discussed about trigonometrical ratios and all the identities, squared identities, quotient identities and reciprocal identities. So we're going to use those identities to solve the questions. Now if you have not understood, I suggest you go back and see that video so that you will understand it better and then come back and solve these questions. Okay, so let's get started. Question, we're going to find the values of all this. So here we have angles like y, x, so we need to find out all the ratios related to these two angles. Here we have x and we have y here. So we need to find out the triangle, right triangle. Okay, so x is in this triangle ABC and angle B is 90 degree, so we can use the relations or the ratios. Okay, and y is in triangle BDC, so we can again use all the relations related to this right angle triangle. Now let's start with we need to find out all the sides first. So here we see that AC is given 25 and CD is given 12. So we can see that in triangle BDC we have two sides, so the third side we can easily find out triangle BDC is a right triangle. Therefore, using Pythagoras theorem we have BC equals to root over, if you know how to find out, right? I'm just doing it. You can use this step directly. BC equals to root over 12 square plus 9 square. Okay, or that's equal to, actually BC square equals to 12 square plus 9 square, so BC equals to this, and that's 12 square is 144 plus 81, that's root over 225. Okay, so that's 15. 225 is 15 square, so BC square is 15 square, so BC is 15. So this is the direct way of writing. So BC is 15. Now if we see, we have got two sides of this bigger triangle. Okay, ABC. So again we can write triangle ABC is right triangle. Therefore, using Pythagoras theorem we know that now here 25 is the hypotenuse. Okay, the side opposite to the 90 degree. So 25 square equals to 15 square plus this square. So 25 square equals to 15 square plus AB square. So AB square equals to 25 square minus 15 square, that's 625 minus 225, that's 400, and that's 20 square. So AB equals to 20. We got AB 20. Now we have all the sides in all the triangles. Okay, in both the triangles we have all the sides. Now you can easily find these values. So let's start with the first one. So the first one is 2 sine y minus cos y equals to 2 sine y. Now corresponding to this angle y, sine y is opposite by hypotenuse, so opposite is 9, and in this triangle hypotenuse is 15, so 9 by 15 minus cos y. Okay, so cos y is adjacent by hypotenuse, so for y adjacent is 12, hypotenuse is 15, so that's 12 by 15. We get 3, 3, 5, so 2 into 3, 6 by 5. minus 3, 4, 5, 4 by 5. That's LCM is 5, so 6 minus 4, 2 by 5. So that's the value for the first one. Now let's see the second one. 2 sin x minus cos x. 2 sin x. X is here in the bigger triangle A, B, C. So corresponding to x, sin x is opposite by hypotenuse. Okay, so for this angle, opposite is BC, and in this triangle we have hypotenuse is 25 AC. So BC by AC, that's 15 by 25. If you want, you can write the sides 2 into BC by AC. It doesn't matter because when you are writing, it's better you write the sides. Minus cos x. Cos x is adjacent by hypotenuse, so that's AB. For x, adjacent is the side AB. So AB by AC. That's 2 into BC is 15 by 25 minus AB by AC, that's 20 by 25. Since the denominators are same, you can cancel it anyway. I'll keep it same like that. LCM is 25. 2 into 15, 30 minus 20, that's 10 by 25. On simplifying, we get 5, 2 by 5. Okay, that also comes to 2 by 5. Now the third one, 1 minus sin x plus cos y. Now you can easily find the ratios. Sin x, I think we've already found it. That's BC by AC, 15 by 25. So 1 minus 15 by 25 plus cos y is, we found out cos y here. So cos y is 4 by 5 or 12 by 15. We can write 4 by 5. Okay, so we can simplify this. LCM, let's take it 5, 3, 5, 5. So now LCM is 5. So we have 5 minus 3 plus 4. 5 minus 3, 2 plus 4, 6. So 6 by 5. Okay, so the value of the third one is 6 by 5. Now let us see the fourth one. 2 cos x minus 3 sin y plus 4 tan x. So that's 2 cos x. We have it, I think, yes, cos x is here. So that's 20 by 25. 2 into 20 by 25 minus 3 into sin y. We have it here, sin y. So that's 9 by 15, right? 9 by 15 plus 4 into, don't copy anything wrong. Okay, when you are copying from the other part, just make sure that you are writing it properly. 4 into tan x is sin x by cos x. Okay, or you can simply use the ratio from the triangle sin tan x. So x, tan x is opposite by adjacent. For this triangle we have opposite is 15 and adjacent is 20. So 15 by 20. Now solve it. You get, you can cancel all this with 5, 5, 4, 5, 5, 3, 3, 3, 5, 5, 3, 5, 4. Okay, so 2 into 4, 8 by 5 minus 3 into 3, 9 by 5 plus 4 gets cancelled, right? So 3. So if you take the LCM of these two, you get 8 minus 1, 8 minus 9 minus 1 by 5. Okay, 8 minus 9 plus 15. Okay, so that's 15 plus 8. Positive numbers are 15 plus 8, 23 minus 9. I get 14 by 5. Okay. And this triangle, we have triangle PQR, angle Q equals to 90 degree. So that means this is a right triangle. We can easily continue with the question, but for your convenience, I am drawing the triangle here. For example, we have a triangle. Angle Q is 90 degrees, so this has to be Q. So let the other sides be vertices be P and R. So PQR, Q is 90 degree, and PQ is given 40. So this is 40, and PR plus QR. Okay, these two sides when you add up, you get 50. So it doesn't matter. Actually, when you have a right angle triangle, whatever the relations like this, PR plus QR equals to 50, or some questions they might give you something like minus or something else, it doesn't matter. So what you are going to do is, if you take one of these sides as x, okay, let us take PR as x or QR as x, it doesn't matter, whichever side you take x, so the other side becomes 50 minus x. So whatever the condition is given, according to that you have to use it. Okay, so let's take one of these sides be as x. Okay, so you can apply the same logic to other questions also, where you have the same kind of things given. So let us take QR as x. Let QR equals to x. Now we know that PR plus QR is 50 centimeter. So in place of first let us write QR equals to 50. So that implies PR plus x equals to 50, and PR equals to 50 minus x. So if this one is x, this one is 50 minus x. Now we can use Pythagoras theorem to find out x and then solve for the given ratios. Okay, so let's solve for x first. Now triangle PQR is right triangle, therefore which one is hypotenuse here? 90 degree opposite side is 50 minus x. So 50 minus x whole square, or you can write h square equals to opposite square plus adjacent square, or perpendicular square plus base square. Now we can apply that. So 50 minus x square equals to opposite is any of the two sides you can take 40 square plus x square. Okay, so you have to solve this. Now a minus b whole square, this is a square 50 square minus 2ab plus b square, so plus b square minus 2ab, 2 into 50 into x, using the expansions, then 40 square plus x square. So if you take x square to that side, x square minus x square, so x square gets cancelled. What is left is 50 square, here you have 40 square, so x square, sorry, x square is already gone, so you have minus 2 into 50, 100x, so minus 100x, let us take it to the right hand side, it becomes plus 100x, and 40 square, let us take it to the other side, so 50 square minus 40 square. Okay, Now you can solve for x. So 100x equals to 50 square minus 40 square. 50 square is 2500. 40 square is 1600. So that's 900. So x is 900 by 100. That's 9. Okay, we got x 9. X equals to 9. So our QR is 9. Therefore, QR equals to 9 and PR equals to 50 minus x. 50 minus 9, that's 41. Okay, so we got this 41. So now we have all the sides. Now once we have found all the sides, now we can use the ratios. Let us erase this first. Now we can use the ratios easily. Sin P. Now for P, where is P? We have this angle as P. Okay, this is P. So for P, sine is opposite by hypotenuse. So for P, opposite is QR and hypotenuse is PR only. That's QR is 9, PR is 41. So 9 by 41. Okay. Now cos P. P is the same angle, so adjacent by hypotenuse. So adjacent is PQ. PQ by PR. That's 40 by 41. The last one is tan R. Now you need to change the angle. So R is here. So for R, tan is opposite by adjacent. Okay, so for tan of this angle R, opposite is PQ and adjacent is QR. So PQ by QR. That's 40 by 9. So 9 4 by 9. Okay. Now in this question, tan theta is given. Now as I told you in the first question itself, in the last class, if you see the video again, you will understand. One of the ratios, you can easily find out all the other ratios. Okay, so using the identities or using the Pythagoras theorem, whatever it is, here I'm going to use the identities to find the ratios like sin theta and cos theta. So tan theta is given, I'm going to find sin theta and cos theta. So I need to know one identity with tan theta, that's I know 1 plus tan square theta equals to sec square theta. Okay, I have that identity, 1 plus tan square theta equals to sec square theta. Now this identity I can use and put the value 1 plus 4 by 3 square. Okay, this is square equals to sec square theta. So that's if you open the bracket, you'll get 16 by 9. So let me write it right hand side first. Sec square theta equals to 1 plus this. Okay, so if I take LCM, I get 9 plus 16, so 25 by 9, that's 5 by 3 whole square. So what is our sec theta? Sec theta is 5 by 3. Now I need to find out sin theta and cos theta. Sec theta is 1 by cos theta. So cos theta equals to 1 by sec theta. That's 3 by 5. Now I can also find sine theta. So sine theta using the other relation, sine square theta plus cos square theta equals to 1. So sine square theta equals to 1 minus cos square theta. That's 1 minus 3 by 5 whole square. That's 1 minus 9 by 25. That comes to 25 minus 9 is 16 by 25. And that's 4 by 5 whole square. So sine theta equals to 4 by 5. Okay. Now from tan theta we got sine theta and cos theta. Now I can easily put the values. Sine theta plus cos theta. Put the values and find the final value. That's sine theta is 4 by 5 plus 3 by 5. That's LCM is 5. 4 plus 3 is 7 by 5. 1, 2 by 5. Now many times you will get this type of questions in the exams where you are given one of these relations and you have to find the value of this. Okay, so this type of questions is very important. Here none of the ratios is given. Okay, so you need to convert this relation, whatever it is given here, you need to convert this into one of the ratios. So we have 5 cos A minus 12 sin A equals to 0. This is our solution. So 5 cos A equals to 12 sin A. Okay, now I can take sin A by cos A, or I can take cos A by sin A, doesn't matter, because sin A by cos A is tan A and cos A by sin A is cot A. So you'll get different ratios, the reciprocal one. And here you get 5 by 12. So tan A is 5 by 12. So if you take the other way, you will get cot A equals to 12 by 5. It doesn't matter which way you take. Now for the rest of the part, there are two ways again to go on from here. So one of the way is when you have tan theta, one of the ratios is given, you can easily find cos A, you can find sin A using whatever method, using the identities we have used in the previous questions. Or there is one other way you can solve it, because we have tan A, we are going to convert all these ratios in the form of tan A. Okay, so the trick is to divide both numerator and denominator by tan A, sorry, cos A, to get tan A. Sin A plus cos A by cos A, and 2 cos A minus sin A by cos A. So what we did is we can divide both numerator and denominator by cos. Anyway, so the next part is sin. Now separating it, sin A by cos A is tan A plus cos A by cos A is 1. Okay, separating the terms. And in the denominator you have 2 cos A by cos A, that's 2, minus sin A by cos A, tan A. So this is one easier trick. So we can put the values 5 by 12 plus 1, 2 minus 5 by 12. Now the rest of the part is simple. Taking LCM in the numerator, you have 12, 5 plus 12, again 12, 24 minus 5, you get 17 by 12, divided by 24 minus 5 is 19 by 12. So now dividing the numerator and denominator by the same number 12, we are getting this. So multiplying both numerator and denominator by 12, we get 12 gets cancelled anyway, so that's 17 by 19. Okay, so this is one of the easier way. You can go by the other method, it doesn't matter, you'll get the same result. And this question is simpler than the previous one. We are going to use this relation to find one of the ratios, 5 sine theta equals to 3. So that means sine theta equals to 3 by 5. Now once we have one of the ratios, we can easily find all the other ratios like sec theta and tan theta. So we can find those values and put the values here. That's a direct one. And there is another one using the trick, like we are going to convert this into sine theta. Okay, so the trick is, we see this is 1 by cos theta and this one is sine theta by cos theta. Okay, so just doing that, sec theta minus tan theta by sec theta plus tan theta. The trick was actually to multiply with cos theta. Anyway, it gets cancelled, it doesn't matter. So we get in the numerator that 1 by cos theta minus sin theta by cos theta. So LCM is sin cos theta. So 1 minus sin theta by cos theta. Okay, so LCM is cos theta. First one is 1 by cos theta minus tan theta is sin theta by cos theta. So LCM is cos theta. In a similar way, this one is 1 by cos theta and plus this is sin theta by cos theta. So LCM becomes cos theta only. So sin theta. So now we can cancel cos theta from numerator and denominator. Actually multiplying both numerator and denominator by cos theta, it gets cancelled. So now I have 1 minus 3 by 5 upon 1 plus 3 by 5. Taking LCM in the numerator and denominator, 5 minus 3 by 5. This is 5 plus 3 by 5. 5 gets cancelled. So you have 2 by 8, that's 1 by 4. Okay, I think this is the simpler way to solve, because going to find out all the other ratios, it takes a bit of time. Okay, this is time saving method. This question is one of the simplest ones. So let us see, sin square theta by cos theta plus cos theta. You have to prove that, okay, left hand side and right hand side. So we are going to start with the left hand side. So if we take LCM, cos theta, what we get is sin square theta plus, we had 1, right? So cos square theta, if you take LCM, you get 1 into cos theta. So cos into cos theta into cos theta is cos square theta. We know sin square theta plus cos square theta is 1. So 1 by cos theta equals to right hand side. So proved. This type of simple questions you might get as sub questions. Okay, so let's move on to the next one. This question is again simple. So that's root over 1 minus sin square theta upon 1 minus cos square theta. So 1 minus cos square theta, you can write it as sin square theta, and then we get, there are 2 ways to solve it anyway. I'll show you both the ways. That's cos square theta by 1 minus cos square theta is sin square theta. What is that relation we have used? Since sin square theta plus cos square theta equals to 1. You need to write the identity you are going to use. Okay, so that's root over cos square cos theta by sin theta whole square. Both are squares. Root over cot theta cot square theta. Okay, cot theta whole square. So that's cot theta. The other way of solving this is 1 minus sin square theta upon 1 minus cos square theta. This is the alternative method. So a particular question can be solved in so many ways. Root over 1 minus sin square theta upon sin square theta. I've already converted only the trigonometry part. Okay, so that's 1 by sin square theta minus sin square by sin square theta is 1. So root cosec square theta minus 1 cot square theta, it's cot theta. Which relation we used? Cosec square theta minus 1 equals to cot square theta. If you remember, 1 plus cot square theta equals to cosec square theta. So I used this identity, and here we have used this one. So whichever way you go, you are going to get the final answer as same. So this is the last one for this class and this exercise. Okay, so if x is given and y is given, you have to prove that this left hand side is given, x square plus y square equals to this. You have to prove. Okay, so let us start with the left hand side, and x square is what we have got, this a cos theta plus b sin theta whole square, right? X is this, so x square is going to be the square of that, plus y square is a sin theta minus b cos theta whole square. You see y is given here, so y square is this. Now you have to open the bracket using the expansion. A square, this is our a, this is our b, a plus b whole square, or you can say x plus y whole square. So this is our x, this is our y, so x square plus y square plus 2ab, that's 2a cos theta b sin theta. Okay, now the second part, a minus x minus y whole square, this is our x, this is our y, so x square, that's a sin theta whole square plus b square, that's b sin theta b cos theta whole square minus 2ab, so minus 2 into a sin theta b cos theta. Okay, now this becomes a square cos square theta plus b square sin square theta plus 2ab cos theta sin theta, or 2ab sin theta cos theta. And the second part we have plus a square sin square theta plus b square cos square theta minus 2ab sin theta cos theta again. So we have plus 2ab sin theta cos theta, this term, and minus 2ab cos theta, this term. So this 2 gets cancelled. We are left with this. Now if we see, in those two terms I can take a square common, then I have sin square, first one is cos square theta plus sin square theta, or we can write sin square theta plus cos square theta, it doesn't matter. In the second two terms, this and this, I can take b square common and I get sin square theta plus cos square theta. So that's a square. Now we know this is 1 plus b square into 1. That's a square plus b square, and we've got our right hand side. So that's proved. So that was simple. You need to identify which identity you are going to use where and how to apply it. Only practice makes you perfect. So keep on practicing and try to remember all the identities and the formula, all the ratios, and you can easily get through all the questions. Hope you have understood the questions and answers solved here. So let me know in the comments below if you have any problem or doubt. Let's stop the class here. That's all for now. See you in the next class. Thank you.